Okay, so in these sections, I will talk about the substitution rule. Now you will see that the format of the substitution rule is basically is actually is the chain rule, right? So again, you will see that the antiderivative of the substitution rule is f of u of x. Okay. Anyway, now when we try to use the substitution rule, we are not using this formula, this form right here, way away. We are going to follow the three procedures. Okay. First, we choose the substitution u as a function of x. Okay. Usually, it is best to choose the inner path of the composition functions. Then the second, take the derivative of the u dx and solve for the quantity dx in terms of du. This is what we call differential. Okay, so when you take 151, you already learned this term differential. And then use the expressions you obtain in step 2 to substitute for dx in the given integral and substitute u for its defining expressions. Okay. Okay. Now let us try to learn the differentials first. Okay. Okay. So now you will see that to this problem, we have u equal to cosine of x squared. Maybe let me put a parenthesis here. Then you will see that if I want to take the derivative, now one thing about this is we actually, if we want to take the derivative, for example, like the u dx, then of course we know that the derivative of cosine is negative sine of x squared, and then we take the derivative of x squared, right? Chain rule, isn't it? So then I will have I will have negative 2x sine of x squared. Okay, this is my du dx. Okay. However, when we try to write the differential, it's kind of like we try to solve for du, and then we move the dx to the other side. Okay. So this is actually is the idea about the differential, or this is the idea how we actually work with du then. Okay, so now it is your turn. Go ahead and try this one. Okay, number 2. So I will have du is 1 over x to the power 4 plus 1. We take the derivative, right? And then we write down dx here. So then I will have du is 4x to the power 3, x to the 4 plus 1 dx. Okay. Okay, so then this is actually is kind of like the idea, okay, of finding the du. Okay. Okay, then now let's try how we actually use substitution then. Now to this problem, then we actually, I would like to take the integral of x squared times x to the power 3 plus 5 raised to the power of negative 9 dx. So you will see that in this case, we know that the derivative of x to the power 3 is 3x squared, which is related to something like this. So therefore, in this case, what I would like to do is I would like to let u be x to the power 3 plus 5 then. And also, you will see that this x to the power 3 plus 5 is the inner function, right? Okay, then let's see how we actually work this out. So we will see that is the u is 3x squared dx. This is what we have. And then now, what we are going to do here is x squared dx. So how about if I have x squared dx is equal to du over 3? Okay. Then what I'm going to do is I'm going to replace the x squared times dx with du over 3. So then I will have u to the negative 9 power, and then now I will have du over 3 then. Okay. Yeah, so then you will see that this is exactly what I would like to do, okay? Or some of you, instead of doing this way, then you could actually solve for, we know that du is equal to 3x squared dx. And then now we could solve for dx. Then I have du over 3x squared. And so I will have this one right here is x squared, and then u to the negative 9. And then we replace dx by du over 3x squared. Okay. And then you will see that you actually you get the same result. Okay. Okay. Then after we have this, then what do? We know that we could take the 1/3 out, and then now we are going to have u to the negative 9, right? So maybe let me rewrite this again. Okay. Then we could work it out the problem. 1/3 u to the negative 8 divided by negative 8 plus c. Okay. Now, of course, I know that the problem is I'm not solving for u, right? I want to work with x. So what I need to do here is I will have negative 1 over 24. And then replace u by x to the power of 3 plus 5 raised to the power of negative 8 plus c. Okay. Then this is actually is my answer now. Okay. Or to make it a better look, then we could have okay. So this is actually is the idea about substitution rule. Okay. Okay. Then now it is your turn. Now go ahead and try to see if you could work on okay the other problems now. Okay. Okay. So then now let us work out number 4. Now in this case, I will let u equal to theta square. Then I will have du is 2 theta d theta. Then. Okay. And then now I will have theta d theta equal to du over 2. Then now I will have this one, it will be psi of u, and will be du over 2 now. Then of course I will have 1/2 psi of u du. And then we know that the integration of psi of u is negative cosine of u. Let's see. And of course my answer will be u is theta square. Okay. And now the next problem. Which one should I let u equal to? Okay. Now you will see that to this one right here, basically the inner functions, it will be the sine of theta, isn't it? So then in this case, of course, I will let u equal to sine of theta now. Then du is cosine of theta d theta. Okay. Then you will see that this is exactly what we want. And now I will have u to the power of 8 du now. Okay. Then I will have u to the 9 over 9 plus c. Okay. And of course, u is cosine. Oh, I'm sorry. U is sine. So theta to the 9 power over 9 plus c then. Okay. Yeah. Okay, then the next problem. To this one, it seems that it's really obvious that my u will be square root of x then, which is x to the 1/2, right? Okay. So therefore, again, du will be 1/2 x to the negative 1/2 dx. Or let me write it down. So in this case, I will have 2 times du is dx over square root of x. Okay. And now I will have to this one. Okay. And it will be secant square of u and 2 times du. Okay. And of course, I take out the 2, then I will have secant square u du. We know that the derivative of tangent is secant square u, right? So therefore, in this case, I will have 2 times tangent of u plus c. Okay. Then, of course, my answer would be 2 times tangent of square root of x plus c. So therefore, again, you will see that this section right here basically is kind of like a mixture of derivative and integrations, right? Okay. And also, you also need to train your eyes to see how we actually work with the substitutions as well. Okay. And now to this one right here. Probably I would like to let u is equal to natural log of x. Okay. The reason is du will be 1 over x dx, or just dx over x then. And we will see that basically this is my du right here. So then now I will have 1 over u squared and then du now. Okay. Okay. Now remember, if you have 1 over u squared, then the best way to take care of this problem right here is change it to u to the negative 2 du. So I will have u to the negative 1 over negative 1 plus c. And of course, I will have negative u is natural log of x. The whole thing raised to the power of negative 1 plus c. Okay, so now the next problem is actually a little bit different. Okay, we still use the substitutions. Now to this one right here, let's see how do we actually do this. First of all, I would like to let u equal to my inner functions, 4x minus 1. So then in this case, I will have du is equal to 4 dx, right? Kind of straightforward. Then I will have du over 4 is equal to dx. Okay. However, there's one thing that is in this case right here. Now, if I write it like this, then I still have the x square root of u and then du over 4. Okay. Then now what I need to do is I need to take care of this x right here. Okay. So how do we actually do this? Then here, this is one thing that I could do, because if u equal to 4x minus 1, then u plus 1 is equal to 4x, and u plus 1 over 4 must be equal to x then. And now I'm going to replace this x by u plus 1 over 4 and multiply to u to the 1/2. and then I have du over 4 now. Is it okay? So sometimes we may need to let's do a little bit more. Okay. Okay. Then now I take out 1/16, and then I will have u plus 1 times u to the 1/2. Okay. Then it will be u to the 1 plus 1/2 is 3/2 plus u to the 1/2 du. Okay. Okay. Then of course now I have 1/16. This one will be u to the 3/2 plus 1 is 5/2 over 5/2 plus u 3/2 plus c. Then this one is 2/5, and u is 4x minus 1, and plus 2/3 4x minus 1 3/2 plus c. Okay. Okay, then now what we could do here is we could simplify here now. Okay. Okay, so I will have 1/4 4x minus 1 5/2 plus 1/24. Okay, so then this is what we have. Okay, so then now the last problem, number 9, is really similar. So let's try to finish this then. Let u equal to 3x plus 8. du is 3 dx. Okay, and of course I will have du over 3 equal to dx here. Okay, and again I have a 3x u equal to 3x plus 8 u minus 8 over 3 is equal to x then, right? And it will be du over 3. Okay, then now I take out 1/9. Okay, so I have 1/9 u to the 12 minus 8 u to the 11. So to this one right here, I will have u to the 13 over 13 minus h times u to the 12 over 12 plus c. And now I will have 1/117. U is 3x plus 8 to the 13 power minus 1/1. I should do this one first. 4, 2, 4, 3. So I will have 2/27 and 3x plus 8 raised to the power of 12 plus c. Okay. 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 And now I hope that you kind of get the idea how do we actually work with the substitutions with indefinite integral. Okay, so the next problem is actually maybe next couple problem is relate to the definite integral. So if we have the lower limit and the upper limit, how do we actually work out the problems? Basically, we need to again change this one from x equal to, maybe let me use this problem. Okay, so we change it from x equal to a and x equal to b in this case to u. Okay, this is what we're going to do. Okay, so let's see. How do we take care of this now? Work with the definite integral. Okay, so to this one right here, then let's see this problem right here. Okay, so I'm going to let u is equal to 4 plus 3x. Okay. Then in this case, du, it will be 3 dx here. Or we will have du over 3 equal to dx, right? And also, one thing about this is now here, what we are going to have is we will change this one to u square root of u and du over 3. Okay. But there's one thing. Remember, my lower limit basically is x equal to 0 to x equal to 7. Right now, we change to u. So what do we need to do is we also need to change my upper limit and the lower limit as well. Okay, so then how do we do this? If x equal to 0, then u will be 4 plus 3 times 0. U is equal to 4. Okay. If x is equal to 7, then I have u is 4 plus 3 times 7. So it will be 4 plus 21, so it's 25. Okay, so then now, when x equal to 0, u is equal to 4. When x equal to 0, when x equal to 7, u equal to 25. So you will see that this is how we actually work out the upper limit and the lower limit when we do the substitutions then. Okay. Okay, then now we could actually do this. So we will have u to the 1/2 plus 1 over 1/2 plus 1 divided between 4 and 25. And now I will have, this is 2 over 3 u to the 3 over 2. Okay. Forgot to multiply 1/3 in front of it. Okay. So what I'm going to have is I will have 2 over 9 and then 25 3/2 minus 4 3/2. So 2 over 9, 5 squared. Okay, so let me work it out. Okay. And now I will have 2 over 9. 125 minus 8. Okay. I will have 117, 3, 30. Okay, so my answer will be 26 then. Okay, so then this is the idea. Okay. Okay, so now it is your turn. Try to see if you could finish again the rest of the problem now. Okay, so to this one, of course, I would like to let u equal to x squared plus 6x plus 1. Right? And du will be 2x plus 6 and dx. Okay, so now what I need is I would like to create a 4x plus 12, which is double this number right here. So what I could do here is I could multiply both sides by 2. Okay. Okay, then, so now I will have this one, it will be 2 du over u squared then. Okay, and then now what I'm going to do, I am going to again check my upper and the lower limit now. Okay, so if x is equal to 1, then u will be 1 squared plus 6 times 1 plus 1. So it's equal to 8. If u is equal to 2, if x equal to 2, then u is 2 squared plus 6 times 2 plus 1. 4 plus 12 plus 1. So it's 17. Okay. Then now I'm going to have this one right here is 2 times u to the negative 2 du. Okay, then now I will have 2 times. So to this one right here, it will be u to the negative 1 over negative 1, evaluate between 8 and 17. So I will have negative 2 times 1 over 17 minus 1 over 8. Okay. Okay, so now the rest of it basically is just algebra now. So I will have negative 2. Okay, so I will have this one will be 8 over 17 times 8 minus 17 over 8 times 17. So it is negative 2 times negative 9 over 136. Okay, so then this is actually is my answer now. Okay. Okay, so now let us try to do number 12. Okay, so to number 12, the inner function, of course, it will be theta squared then. And I will have du is 2 theta d theta. Okay, and of course, I will have du over 2 is theta d theta then. Now I will have tangent of u and du over 2. So again, I would like to work with the upper limit and the lower limit. So if theta is equal to 0, then u is equal to 0. If theta equal to 1, then u is equal to 1. So it's still between 0 and 1, huh? Okay, so now to this one, how do we actually take care of this? So we could actually, we know that tangent is psi of u over cosine of u. Okay. Then now we could let w is equal to cosine of theta. Then cosine of u. Then if this is the case, we will have dw is equal to negative psi of u du. Okay. Then now I will have dw is negative dw is psi of u du. Okay, now you have to be really careful about here. So first we have theta is equal to 0 and 1. And then now we change this one to u is equal to 0 and u is equal to 1. Okay. And now to this one right here, we need to work with the w now. Okay, so anyway, let's try this. So to this one right here, I will take out the 1/2. And then psi of u du is negative dw over u over w then. Okay. Okay, then now how about my upper limit and the lower limits now? Okay. To this one, if u is equal to 0, then w is equal to cosine of 0, then which is equal to 1. If u is equal to 1, then w is equal to cosine of 1. Okay. So then now I will have from 1 to cosine of 1 then. Okay. Okay. And now to this one, I will have negative 1/2 natural log of w. Okay. Divided between 1 and cosine of 1. Okay. So, and now I will have negative 1/2 natural log of cosine of 1 minus natural log of 1. And of course, we know that natural log 1 is equal to 0. So my answer will be negative 1/2 natural log of cosine of 1. Yeah, so then this is actually is the answer that we have here. Okay. Okay. Then how about number 13 now? So this one right here, I think that is a little bit easy. So because again, we could let u equal to cosine of x, right? Then we will have du is negative psi of x dx in this case. Okay. And of course, psi of x dx is equal to negative du. Okay. And now I will have this one, it will be u to the power 3, and the name side, so du. Okay, so I need to work out with the upper and the lower limits. So if x is equal to 0, then u will be cosine of 0, which is 1. If x is equal to pi over 2, then u is cosine of pi over 2, which is 0. And now I will have negative u to the power 4 over 4, while between 1 and 0. So I will have negative 0 minus 1 over 4. So my answer will be 1 over 4. Okay, so now let us look at the last problem. Now the last problem is to see how we actually work out the problem like this one. Okay, so to this one, we have f prime of x and f of x to the power of 3, f prime of x dx. Then now, if I use the substitution, I let u equal to f of x, then right away we know that du will be f prime of x dx. Okay. Okay. So then now I will have this one will be u to the power 3 du. Okay. Then of course it will be u to the 4 over 4 plus c. Then the answer will be f of x raised to the power 4 power over 4 plus c. Then this is my answer right here. Okay, so then we work out a lot of problems, okay, in this section right here, because I believe that again, practice is actually make it perfect, right? So therefore, again, now try to work out more problem in the back of your textbook and to get like familiar with the substitution rule. Okay, thank you. See you next time.